A digital identity is information on an entity used by computer systems to represent an external agent. That agent may be a person, organization, application, or device. ISO IEC 24760-1 defines identity as set of attributes related to an entity. The information in digital identities is used by computers to make decisions about how to interact with external agents. It allows a computer to answer two basic questions: with which external agent is it interacting? Has it interacted with an external agent in the past? The information contained in a digital identity allows these questions to be answered without the involvement of human operators. Digital identities allow our access to computers and the services they provide to be automated, and make it possible for computers to mediate relationships. The term digital identity has also come to denote aspects of civil and personal identity that have resulted from the widespread use of identity information to represent people in computer systems. Digital identity is now often used in ways that require data about persons stored in computer systems to be linked to the civil or national identities. Furthermore, the use of digital identities is now so widespread that many discussions refer to digital identity as the entire collection of information generated by a person's online activity, especially where that information is publicly available and can be used by others to discover that person's civil identity. In this wider sense, a digital identity is a version or facet of a person's social identity. This may also be referred to as an online identity. The legal and social effects of digital identity are complex and challenging. However, they are simply a consequence of the increasing use of computers, and the need to provide computers with information that can be used to identify external agents. Background: a critical problem in cyberspace is knowing with whom one is interacting. Currently, there are no ways to precisely determine the identity of a person in digital space, even though there are attributes associated to a person's digital identity. These attributes or even identities can be changed, masked, dumped, and new ones created. Despite the fact that there are many authentication systems and digital identifiers that try to address these problems, there is still a need for a unified and verified identification system. Thus, there are issues of privacy and security related to digital identity. Related terms: subject and entity. A digital identity may also be referred to as a digital subject, a digital entity, and is the digital representation of a set of claims made by one party about itself or another person, group, thing, or concept. Attributes, preferences, and traits. Every digital identity has 0 or more identity attributes. Attributes are acquired and contain information about a subject, such as medical history, purchasing behavior, bank balance, age, and so on. Preferences retain a subject's choice, such as favorite brand of shoes, preferred currency. Traits are features of the subject that are inherent, such as eye color, nationality, place of birth. While attributes of a subject can change easily, traits change slowly, if at all. Technical aspects: trust, authentication, and authorization. In order to assign a digital representation to an entity, the attributing party must trust that the claim of an attribute is correct and associated with the person or thing presenting the attribute. Conversely, the individual claiming an attribute may only grant selective access to its information, e.g., when one proves identity in a bar or PayPal authentication for payment at a website. In this way, digital identity is better understood as a particular viewpoint within a mutually agreed relationship than as an objective property. This contextual nature of digital identity is referred to as contextual identity. Authentication. Authentication is a key aspect of trust-based identity attribution, providing a codified assurance of the identity of one entity to another. Authentication methodologies include the presentation of a unique object such as a bank credit card, the provision of confidential information such as a password of the answer to a pre-arranged question, the confirmation of ownership of an email address, and more robust but relatively costly solutions utilizing encryption methodologies. In general, business-to-business authentication prioritizes security while user-to-business authentication tends towards simplicity. Physical authentication techniques such as iris scanning, handprinting, and voice printing are currently being developed and in the hope of providing improved protection against identity theft. Those techniques fall into the area of biometry. Whilst technological progress in authentication continues to evolve, these systems do not prevent aliases being used. The introduction of strong authentication for online payment transactions within the European Union now links a verified person to an account, where such person has been identified in accordance with statutory requirements prior to account being opened. The concept of reliance authentication makes use of pre-existing accounts to piggyback further services upon those accounts, providing that the original source is reliable. The concept of reliability comes from various anti-money laundering and counter-terrorism funding legislation in the USA, EU 28, Australia, Singapore and New Zealand, where second parties may place reliance on the customer due diligence process of the first party, where the first party is, say, a financial institution. An example of reliance authentication is PayPal's verification method. Authorization. Authorization is the determination of any entity that controls resources that the authenticated can access those resources. Authorization depends on authentication, because authorization requires that the critical attribute must be verified. For example, authorization on a credit card gives access to the resources owned by Amazon, e.g., Amazon sends one a product. Authorization of an employee will provide that employee with access to network resources such as printers, files, or software. For example, a database management system might be designed so as to provide certain specified individuals with the ability to retrieve information from a database but not the ability to change data stored in the database, while giving other individuals the ability to change data. Consider the person who rents a car and checks into a hotel with a credit card. The car rental and hotel company may request authentication that there is credit enough for an accident, or profligate spending on room service. Thus a card may be refused when trying to book the balloon trip, though there is adequate credit to pay for the rental, the hotel, and a balloon trip. Then when the person leaves the hotel and returns the car, the actual charges are authorized. Digital identifiers. Digital identity fundamentally requires digital identifiers. Strings are tokens that are unique within a given scope. Identifiers are the key used by the parties to an identification relationship to agree on the entity being represented. Identifiers may be classified as omnidirectional and unidirectional. Omnidirectional identifiers are intended to be public and easily discoverable, while unidirectional identifiers are intended to be private and used only in the context of a specific identity relationship. Identifiers may also be classified as resolvable and non-resolvable. Resolvable identifiers, such as a domain name or email address, may be dereferenced into the entity they represent, or some current state metadata providing relevant attributes of that entity. Non-resolvable identifiers, such as a person's real-world name or a subject or topic name, can be compared for equivalence but are not otherwise machine understandable. There are many different schemes and formats for digital identifiers. The most widely used is Uniform Resource Identifier and its internationalized version, Internationalized Resource Identifier, the standard for identifiers on the World Wide Web. Open and lightweight identity are two web authentication protocols that use standard HTTP URIs. For example, Digital Object Architecture. Digital Object Architecture provides a means of managing digital information in a network environment. A digital object has a machine and platform-independent structure that allows it to be identified, accessed, and protected as appropriate. A digital object may incorporate not only informational elements, i.e. a digitized version of a paper, movie or sound recording, but also the unique identifier of the digital object and other metadata about the digital object. The metadata may include restrictions on access to digital objects, notices of ownership, and identifiers for licensing agreements, if appropriate. Handle system. The handle system is a general-purpose distributed information system that provides efficient, extensible, and secure identifier and resolution services for use on networks such as the Internet. It includes an open set of protocols, a namespace, and a reference implementation of the protocols. The protocols enable a distributed computer system to store identifiers, known as handles, of arbitrary resources and resolve those handles into the information necessary to locate, access, contact, authenticate, or otherwise make use of the resources. This information can be changed as needed to reflect the current state of the identified resource without changing its identifier, thus allowing the name of the item to persist over changes of location and other related state information. The original version of the handle system technology was developed with support from the Defense Advanced Research Projects Agency. Extensible Resource Identifiers. A new OASIS standard for Abstract, Structured Identifiers (XRI) adds new features to URIs and iris that are especially useful for digital identity systems. OpenID also supports XRIs, and XRIs are the basis for INAMEs. Policy aspects. There are proponents of treating self-determination and freedom of expression of digital identity as a new human right. Some have speculated that digital identities could become a new form of legal entity. Taxonomies of identity. Digital identity attributes, or data, exist within the context of ontologies. A simple example of a taxonomy is, a cat is a kind of animal. An entity represented in this ontology as a cat is therefore invariably also considered an animal. Quote, in establishing the contextual relationship of identity attributes to one another, taxonomies are able to represent identity in terms of predefined structures. This in turn allows computer applications to process identity attributes in a reliable and useful manner. XML has become a de facto standard for the abstract description of structured data. Taxonomies inevitably reflect culturally and personally relative worldviews. Consider two possible elaborations of the above example. A cat is a kind of animal. A domestic cat is a kind of cat and is a pet. A cat is a kind of animal. A domestic cat is a kind of cat and is edible by humans. Someone searching the first taxonomy for pets would find domestic cat, whereas a search of the second taxonomy for foodstuffs would yield the same result. We can see that while each taxonomy is useful within a particular cultural context, a set of contexts, neither represents a universally valid point of view on domestic cats. The development of digital identity network solutions that can interoperate taxonomically diverse representations of digital identity is a contemporary challenge. Free tagging has emerged recently as an effective way of circumventing this challenge by effectively flattening identity attributes into a single, unstructured layer. However, the organic integration of the benefits of both structured and fluid approaches to identity attribute management remains elusive. Networked identity relationships within a digital network may include multiple identity entities. However, in a decentralized network like the Internet, such extended identity relationships effectively require both the existence of independent trust relationships between each pair of entities in the relationship and a means of reliably integrating the paired relationships into larger relational units. And if identity relationships are to reach beyond the context of a single, federated ontology of identity, identity attributes must somehow be matched across diverse ontologies. The development of network approaches that can embody such integrated compound trust relationships is currently a topic of much debate in the blogosphere. Integrated compound trust relationships allow, for example, entity A to accept an assertion, a claim about entity B by entity C. C thus vouches for an aspect of B's identity to A. A key feature of compound trust relationships is the possibility of selective disclosure from one entity to another of locally relevant information. As an illustration of the potential application of selective disclosure, let us suppose a certain Diana wished to book a hire car without disclosing irrelevant personal information. As an adult UK resident with a current driving license, Diana might have the UK's driver and vehicle licensing agency vouch for her driving qualification, age and nationality to a car rental company without having her name or contact details disclosed. Similarly, Diana's bank might assert just her banking details to the rental company. Selective disclosure allows for appropriate privacy of information within a network of identity relationships. A classic form of networked digital identity based on international standards is the white pages. An electronic white pages links various devices, like computers and telephones, to an individual or organization. Various attributes such as X509v3 digital certificates for secure cryptographic communications are captured under a schema and published in an LDAP or X500 directory. Changes to the LDAP standard are managed by working groups in the IETF, and changes in X500 are managed by the ISO. The ITU did significant analysis of gaps in digital identity interoperability via the FGIDM focus group on identity management. Implementations of X500 and LDAPv3 have occurred worldwide but are primarily located in major data centers with administrative policy boundaries regarding sharing of personal information. Since combined X500 and LDAPv3 directories can hold millions of unique objects for rapid access, it is expected to play a continued role for large-scale secure identity access services. LDAPv3 can act as a lightweight standalone server, or in the original design as a TCP/IP-based lightweight directory access protocol compatible with making queries to a X500 mesh of servers which can run the native OSI protocol. This will be done by scaling individual servers into larger groupings that represent defined administrative domains, which can add value not present in the original white pages that was used to look up phone numbers and email addresses, largely now available through non-authoritative search engines. The ability to leverage and extend a networked digital identity is made more practicable by the expression of the level of trust associated with the given identity through a common identity assurance framework. security issues and privacy. With automated face recognition, tagging, location tracking and widespread digital authentication systems, many actions of a person become easily associated with identity as a cause. Sometimes privacy is lost and security is subverted. An identity system that builds on confirmed pseudonyms can provide privacy and enhance security for digital services and transactions. Cyberspace creates opportunities for identity theft. Exact copies of everything sent over a digital communications channel can be recorded. Thus, cyberspace needs a system that allows individuals to verify their identities to others without revealing to them the digital representation of their identities. Anonymous, pseudonymous attribute systems. An anonym is an authenticated attribute that is not linked to an identifier. An anonymous identifier identifies the person once. If it is used more than once, becomes a pseudonym. A pseudonym is an identifier associated with attributes but with no permanent identifier. Legal issues. Claire Sullivan presents the grounds for digital identity as an emerging legal concept. The Identity Cards Act confirms Sullivan's argument and unfolds the new legal concept involving database identity and transaction identity. Database identity refers to the collection of data that is registered about an individual within the databases of the scheme and transaction. Identity is a set of information that defines the individual's identity for transactional purposes. Although there is reliance on the verification of identity, none of the processes used are entirely trustworthy. The consequences of digital identity abuse and fraud are potentially serious, since in possible implications the person is held legally responsible. Business aspects. Corporations have begun to recognize the Internet's potential to facilitate the tailoring of the online storefront to each individual customer. Purchase suggestions, personalized adverts and other tailored marketing strategies are a great success to businesses. Such tailoring, however, depends on the ability to connect attributes and preferences to the identity of the visitor.